Dear students, today's topic is a spring mass system, and in this topic we are going to find an expression for the period of oscillation of a spring mass system. And the spring mass system consists of a weightless spring which is clamped at its one end and a mass M is attached at the other end. And the spring and the mass are kept on a frictionless horizontal surface. And if a force is applied on the mass so as to stretch or compress the spring and release, then the motion of the mass is simple harmonic. When the spring is compressed or extended by an amount x from its mean position, then there will be a restoring force F acts in the spring. And if x is the displacement of the mass at any time, then the restoring force exerted by the spring F is equal to, or F will be proportional to this displacement. And this F is acting opposite to the direction in which the mass is displaced. Or we can represent this F as F is equal to minus Kx, where K is the force constant or spring constant. And from the equation F is equal to Kx, K can be defined as K is equal to F by X. That is, the force constant of a spring can be defined as the restoring force per unit displacement of the spring. But we know that from Newton's second law, the force F is equal to ma, where A can be represented as d square x by dt square, where x is the displacement of the mass at any time. Therefore, this force can be represented as m into d square x by dt square. And also this force can be represented as F is equal to Kx. And equating these two equations, we get m into d square x by dt square is equal to minus Kx, or d square x by dt square plus k by m into x equal to 0. And comparing this equation with the standard equation representing the simple harmonic motion, that is d square x by dt square plus omega square x equal to 0. And if we compare these two equations, then we get omega square is equal to k by m, or omega is equal to root of k by m. This shows that the oscillation of a loaded spring executes simple harmonic motion with an angular frequency omega is equal to root of k by m. Therefore, the period of oscillation of a spring mass system can be represented as T is equal to 2 pi by omega, but omega is root of k by m. Therefore, the period T is equal to 2 pi into root of m by k. That is, the period of oscillation of a spring mass system depends on the mass attached to the spring and also the force constant on the spring constant of the spring.